Myself Saritha IG. I will be handling control system for 4th semester telecommunication or electronics and telecommunication engineering students. So, as we all studying embedded system, designing embedded system and implementing embedded system applications, the main prerequisites for embedded system is control system. The basic principle of embedded system is mainly based on the control system only. So, here the aim and plan of the control system, why control system, what is the control system, and feedback, what is the subject about. So, why control system is required? As I told, embedded system is mainly based on the control system design. So, all embedded applications are mainly based on the control system. To control the system, we need control system, or to control the embedded system, we need control system. So, here it is given application, the rover was built to work in a contaminated area. How the rover is controlled to work as a work in the contaminated area. Then this is one application, and again here the robots used in the surface mining, planetary exploration, to explore your planetary as well as mining. So, robots were used where it is controlled by your control system. So, mobile road led follow example is one of the application of control system as well as application of embedded system. The robot is mobile robots are used as a one application in the embedded system where it is controlled by your control system. Why control system? As we know that modern society have a sophisticated control system which are crucial to their successful operation. So, reason to build control system is mainly to reduce the power amplification, to improve the power amplification and strengthen the signal, to perform the remote control operation as in the robot, and convenience of input form and compensation for disturbances. So, what is control system? Before learning control system, we need to learn what is system. A system is a combination of multiple components. Multiple components means for example, I can give a classroom. A classroom consisting of chair, table, light, fan, everything. So, the system is where it takes the input and give the output. Irrespective of the output, it takes any input and give the respective output based on the input. But what is control system? When the control system will be operated. So, the control system is a system which is controlling the operation of input and output. So, for example, here, so a system is taking input, a stimulus input is given at the input side. So, that is desired response, and actual response is taken at the output. So, system consisting of a plant, it may be controlling the action of the input as well as output. So, that is why it is called as control system. So, control system is, it is a regulated system where it is regulating the operation of input as well as output. For example, I can give a classroom teaching classroom which consisting of a teacher and student, where teacher is regulating the student. That can be considered as a one example for control system. And fan can also be considered as a control system, where switch on the button will be controlling the action of your fan. So, soon after you switch on the button, the fan will be running. So, that is also one control system. So, the different application and example for your control system. So, next, a dynamic response. So, we can see that there are input commands are given here, and the response is taken. So, the graph is response versus time, where you have given input command. So, transient response, steady state error. This you will be learning in your third module. So, that is transient response of the system. So, time domain analysis of the system in a control system. So, the block diagram of control system, it consisting of input transducer, controller and summing junction, processor plant and the summing junction again output. So, this is for open loop system. There are two type of control system we have. So, one is open loop system, as name itself indicating it is open. So, the accuracy of the output is not depending upon the input. So, you may be given input, you will be getting output. So, irrespective of output condition, the open system will be taking input, giving output. And what is closed loop control system? For example, I can give the open loop control system fan. I just switch on the button, the fan will run. So, irrespective of the accuracy of the fan or speed, whatever, the fan will be running based on the switch button. So, but what is the accuracy of the fan? We does not know. So, when the closed loop system will be when the main requirement to be a good control system is three main requirement of good control system is time, speed and stability, accuracy, speed and stability. These are the three main requirement of good control system. So, to meet our speed, to meet our accuracy, to meet our stability, it should be a good control system. So, to meet this we need a closed loop control system. So, to meet a good accuracy in the control system, we need a closed loop control system. A closed loop control system, as name itself indicating, it is closed. So, open loop control system is also called as non-feedback control system, whereas closed loop control system is called as feedback control system. So, depending upon the output response, based on the accuracy of the output, each time the output is fed back to your input condition to give a accuracy of the process. So, here input transducer is taking a input and the controller is controlling the action. So, after controlling, the plant process the controlling action, then you will be getting a output. That may be similar in your open loop control system, but in our open loop control system, the output is not fed back to your input, which may be giving any result. So, whereas in case of closed loop control system, to get accuracy result, each time the output is fed back to our input. So, the output transducer or the sensor keep measuring the value of the output along with the input. So, the difference of the output and input will be leading into generate a good accuracy. So, I can give an example for closed loop control system as in the library system, the books are placed in the rack, person is standing nearby the rack. So, brain is considered as a controller here and hand is considered as a plant and eye is measuring the distance between the person and rack. So, as soon as the eye give a error value, that is distance between the person and rack. So, the brain will be insisting the hands to extend the hands to reach the rack, so that the person can extend his hands to collect the book. So, that is why input reference position of the book and desired position of the book or hand, that is measured by our eyes. So, there are different advantages and disadvantages in the open loop control system and closed loop control system. As name itself indicating, open loop control system is simple, quite easy to maintain, and open loop control system is faster than closed loop control system. Open loop control system may not be giving accurate result, whereas closed loop control system will be generating accurate result, and bandwidth is less in open loop control system and bandwidth is more in closed loop control system. And cost wise, the open loop control system is less expensive and closed loop control system is more expensive. Time consumption is less in open loop control system and time consumption is more in closed loop control system. And stability condition, the open loop control system is stable for all the environmental condition and closed loop control system is not stable for all the environmental conditions. So, these are the feedback, that is open loop control system is also called as a feedback closed feedback system. So, feedback is a key tool that can be used to modify the behavior of the system, and behavior altering effect of feedback is a key mechanism which that control engineering exploit deliberately to achieve the objective of the action on the system to ensure the desired performance specification are achieved. So, closed loop control system with the sensor feedback. So, here R of t is considered as response time and Y of t is output or desired response time, and the controller controlling the action, plant is processing the action. So, measurement and signal transmission system is measuring the error between the response time and desired output. So, response of the position control system showing effect of high and low controller gain on the output response. So, this may be again response versus time. So, output with a high gain indicating with a high peak, and input is given at the for the step input response, and output with a low gain, it is indicating here. So, what is the control system engineer trying to achieve? So, first understand the broader picture of the application to best apply a suitable control system. As I told, to be a good control system, it need to be generate a good accurate result, need to be faster, need to be stable for all the time. So, that is what to a good control system is a system that will generate a response quickly and without oscillation. So, good transient response to be generated and have a low error once settled, good steady state response should be generated and will not oscillate widely or damage the system is stable for all the environmental conditions. So, control system design cycle here it determine the physical system and specification from the requirement in the step 1. Step 2, draw it. This is common for all the control system design cycle. First we need to determine a physical system and specification from the requirement, then draw functional block diagram, then transform the physical system into schematic, then use the schematic to obtain a block diagram, signal flow diagram or state space representation. If multiple blocks are there, reduce the block diagram to single block or closed loop system. So, the main intention of control system is to reduce the closed loop control system is to reduce the complexity. So, we need to reduce the complex of design of the blocks. So, analyze, design and test to see that requirement and specifications are met. So, scope of the subject. So, mainly from this course, from the control system course, mathematical the student will be able to understand mathematical modeling of the dynamic system like a transfer function representation and stability concepts and transient response for the first and second order system, root locus analysis and frequency response technique using Nyquist criterion and Bode plots as well as polar plots. So, at the end of the course, the student will be able to model the control system using transfer function, stability and transient response analysis, simple compensator design like lead and lag compensator and lag compensator for linear time invariant system. A linear time system satisfy the principle of superposition as well as homogeneity, and ordinary differential equation that has a constant coefficients. So, summary of this, we have introduced why do we need a control system, what is the control system, what is the main performance we care for control system, and feedback is very important for the control system, and what will this course will cover. The course will be covering as I told. So, it is the student will be able to model the control system by obtaining a transfer function for various concepts like time domain analysis, stability analysis and the accuracy, and the student will be able to design or implement embedded system with the help of control system, or the student will be able to model or design or implement the robot using the control the principle of control system. So, the certain problem in a control system is to find a technically feasible way to act on a given process, so that process behave as a closely as possible to some desired behavior. Furthermore, this approximate behavior should be achieved in the face of uncertainty of the process and in the presence of the uncontrollable external disturbances acting on the process. That is what stability is analyzed. So, the next class we will move on to the review of Laplace transform.